Okay, so we're going to start shorthand notation this time, and I picked silicon to start with. Silicon has an atomic number of 14. We're going to, I'm going to just go over what we did yesterday, since this is a relatively small atom, and we'll do the full configuration with the orbital notation, and then we'll do the shorthand notation, okay? No, just you can wait. I'm doing this mainly for the ones who are out, like Olivia and Tate. Okay, so you follow the diagonal rule whenever you put electrons into atoms, because according to the Aufbau principle, they build up and they start with the lowest energy electrons and build up to the higher energy ones. And it's called the Aufbau principle and the diagonal rule. The diagonal rule because you have to follow the diagonal arrows. You can't go straight across from left to right, okay? So if you have 14 electrons, that's a what? What's that line represent? Anybody remember? Starts with O. Orbital, okay? And I'm going to put the first two in this. And why do I have to put them in opposite directions? Because they have like charges and they have to go opposite, okay? Okay, so I'm taking away 2. I have 12 left. I come to the end of this arrow, go up to this one, and I'm going to go to 2s. And 2s is the next energy level. I have 10 left. And at the end of 2s, I go up here to 2p. And how many does p have? Yeah, or 3 orbitals. And why am I doing them like this? Whose principle? Or whose rule? Well, I put 1 in each one until, yes. Whom's rule says you got to put 1 in each before you can put the second one in. Okay? Say what, Tate?
Now you have 4 left?
Yes.
Yeah, I'm not straight. You can see it.
You are?
Can you zoom in just put that?
Mm-hmm.
So every 2 is 1 orbital? So that's
Yes.
why you put 3 of those little things on top?
Yeah. I have 3 orbitals, and you can put 2 in each one. And when you fill one that has multiple orbitals, you have to put 1 in each of them first before you can put the second one in. That's Hund's rule. And then, so I've got 4 left. I'm going to go to 3s2. That takes away 2. And next, after 3s2, I go to 3p. How many am I going to have in 3p? 2. And you have to have them in separate orbitals because you can't put 2 in one until you have 1 in all of them. Okay? So that's how we would do silicons. Orbital notation, the arrows in the orbitals are orbital notation. This is the configuration, electron configuration. Okay?
Okay, I don't get the last one.
This one?
We just did the 2 up.
Hund's rule says you can't put 2 in one of these orbitals unless there's 1 in all 3 of them first.
So since we had to change it, you just...
Yeah. If there were 6, there'd be 1 up, 1 down in all of them. Okay? Okay, and I'm going to do a bigger one that you'll see it in. Okay? Now, remember what we said yesterday. Silicon is in what block? The P. This is D, this is S, and this is F, okay? It ended in the P block because it ended in the P sublevel because it is in the P block, okay? Okay. Now, okay, and there's only 2 of them in there because you can only have, this would be P1, P2, P3, P4, P5, P6. Okay? It's really easy to keep up with it on the periodic table. Okay? It stopped here. It stopped in this P block because the first 2 in the 3s were 1 and 2 here. And then this is 3p1, 3p2, 3p3, 4, 5, 6. Okay? You just go along there. There's only 6 electrons that can be in the p, and they would be in the p block if they end right here. Okay? Now, the shorthand notation, in the shorthand notation in the rules I gave you, we're going to still do silicon, okay? You find your element on the periodic table, okay? Then you go up one level and all the way to the right, okay? And we're going to use neon. Okay. Now, when I put this right here, this tells me that everything about silicon is just like neon up until okay, as you come down here, oops, okay, as you come down here, all of these end in a P6, and it depends on what hold on, period they're in as to which P6 they end in, okay? So, silicon is here, I go up and over, and that's why I chose neon. So that tells me every electron in silicon is just like neons up through 2p6. Where do you start after 2p6?
3s2.
So, silicon has 14, neon has 10. All I need to deal with are 4 electrons. Okay? We stopped at 2p6 with neon, so we start at 3s2, and that takes away 2. I have 2 left. We go to 3p2, and that is shorthand notation.
Do we not have to put the orbitals?
No, not on shorthand notation.
So where'd you get your 3?
Okay, silicon has 14 electrons, right? Neon has 10. Okay? So, and like I said, everything about silicon is just like neon up through 2p6.
I got
So,
that. The only part I didn't get was like that very last step you did.
okay. So I take 10 away from the 14 of silicon. That's neon, that's silicon. I have 4 electrons left. After 2p6, we go to 3s2. That takes away 2. And then we go to 3p, but we can't put 3p6 because we don't have 6. We only have 2. So I take those other 2 away and put them here. And this is the shorthand notation for silicon.